Let's begin with the demonstration of a CPS project, obstacle detection for visually impaired. So as we already know, the feedback loop works in a way that the sensor senses the obstacle given to the Atmega 328 port. The actuators are buzzer, vibration motor and LED. The feedback loop as a visually impaired individual, in this case I am demonstrating as a person who is reacting towards the obstacle, has to react to the obstacle to make changes in the environment or feedback or making it towards the ideal state. Let's move towards the analysis part. The analysis is completely done by Petri Nets. So whenever the token is in the state, we know that the boundedness of a Petri Net is the state can only be one. Like when it runs only one state at a time. So when we are in idle state, we cannot be in a feedback stage. So whenever the obstacle is detected, the token moves to the P3 of feedback 1, giving the feedback for 9 seconds continuously. And if the obstacle still stays there, we move the token towards the feedback 2, furthermore towards feedback 3, decreasing the delay of the sensor feedbacks, actuator feedbacks towards the user or a visually impaired people. So moving on to the circuit, it's a clean circuit with all the sensors, actuators and microcontroller intact. Easy to wear with elastic strap and adjustable. So on your palm of your hand with the supply of 5 volts, I'm giving this supply via power bank. We can also use many other devices where outlet is around 5 volts. So when we plug it in, we see that when we relate with the analysis, the token moves or the system moves from P1 to P3 whenever the obstacle is detected. Further moving towards feedback 2 and then further moving for feedback 3, it moves towards the next feedback only when the obstacle stays, and whenever there is no obstacle, at least for 1 second, we move back towards the initial stage. So plugging it in, the system turns on. The Arduino Nano gives you the power on LED light which blinks up or showcases that the system is working. The loop start processing and the sound waves are bombarding right now. There is nothing in the range. The range is set towards 90 centimeters. So whenever the obstacle is detected, it is ideal. It is an ideal range for the visually impaired to react accordingly. So now normally by hand it reacts, and when there is no obstacle, we are back again to initial state and then showcasing the continuous loop right now. So we are bombarding the waves towards the wall. We are in feedback 1, 1.5 second interval for 9 seconds. We are in feedback 2, 1.2 second interval again for 9 seconds. We are in feedback 3, last. It continuously gives you the feedback for 1 second interval. We move away from the obstacle for at least 1 second. It resets back to initial state. Now whenever we turn it on again, it goes towards again the feedback 1. So relating it with the analysis, it actually behaves accordingly what we demonstrated right now. So yeah, that's about the demonstration. We'll move to the analysis part right away after demonstration. Thank you so much.